Yeah, yep, okay.
Okay, first
Yeah.
step, second step, then what's the next step? Okay, I'll show you. So this is that position, right? So I can go around, but then it's not gonna go anywhere because I cannot go to the nitrogen. Why can't I go to the, well, actually, hang on, I can go to the nitrogen, sorry. I can go to the nitrogen. Yeah. So that next arrow is actually going to that nitrogen. So now you have a carbon-nitrogen double bond. Hey, but hang on, nitrogen cannot form 5 covalent bond because 1, 2, 3, 4, 5. Nitrogen only has 2s and 2p, right? What's the maximum electron 2s and 2p can hold together? If nitrogen is in second period, so maximum 8 electron, maximum 4 covalent bond, right? So that's why you can have maximum 4 covalent bond. You cannot have 5. Hey, guess what? This is a nitrogen-oxygen double bond. What can you do? You can break, and then you can get this next step.
Yeah, because it's alternating.
Yep. Do you get the step now?
Yeah.
You sure? Do you want to draw it on yours, and then I can see?
Okay. I'll redraw.
Okay. So this is for the position number 3.
Okay. Plus, minus. So something like, wait, yeah. Can you see?
Lone pair donates. Nope, that is wrong. You should have gone the other way. You have done wrong stuff. On your benzene ring, use the one on your benzene ring, use the one on the left. So push it to the left instead of to the right first. Follow the arrow. Follow your arrow. Instead of going to the right in the benzene ring, go left and then move it around.
Okay.
It needs to be a natural movement. This is called curly arrow, okay? The electrons are moving. You cannot just randomly draw here and there. Otherwise, your mechanism is all wrong, okay? Do you get it now?
Yeah.
So show me once you're done, and then I can see.
Let me see. Wait.
What's wrong?
Wait, wait. Oh. Wait. Yeah, I don't know. Not sure.
So that way. Wait, hang on. Oops, I'm sorry. Your first one was correct already. Your first one was correct. Sorry. I misread. Your first one was correct. Your first one was correct. Okay, cool. So when you move the arrow around, you can get a resonance structure. A resonance structure means a different structure. A resonance, RESONANC. It means a different structure where the electron has moved around, and then I can draw the structure like this now. Hang on. That doesn't make sense at all. I'll tell you what I've done wrong. This is wrong. Can you see why this is wrong? So what I'm telling you, what we have done just now is wrong, because this carbon is got 4 bonds. When you form this bond, you are making this carbon 5 bond. But when you move this electron here, that carbon will still be 5 bond. Like this. 1, 2, 3, 4, 5. And guess what? It doesn't like to be this, right? So it can't go here at all. It can't do
Yeah.
this at all. So this is wrong. Can you try with the? Can you try to see if you can do with the position number 4? So
Position.
draw with position number 4. Yeah. So
Okay.
draw a different nitro group, and let's see if you can get it or not.
Okay.
Remember, carbon form 4 bond only. Yeah.
Yeah.
See if you can get it or not. Can or cannot?
So, wait. Double bond. Two, three, four.
After mine, you can definitely do it for the position 4 one. You can definitely delocalize into the NO2. It's just a matter of your arrow pushing and see whether I can get you to do it a bit faster or not. Stop doubting yourself, okay? You gotta pick up from where you mess up and then see if you can learn or not. Go in, go in, go
Wait,
in.
I forgot to draw
You forgot the
the
last
arrow.
part. You forgot the last part. The nitrogen cannot form 5 bond. You forgot the last part. You forgot the very last bit. So everything is correct, but you forgot the last bit. The nitrogen cannot form 5 covalent bonds. So what must happen?
The oxygen.
Yeah.
I forgot to push that. Yeah.
Yeah. Can you draw the resonance form? Can you draw the resonance? So you've done all this arrow pushing. Can you draw the resulting form? What will it look like with all the correct charges? So next to it, and then I can see what you've drawn. Come on, do it a bit faster.
Sorry. Or 1, 2, 3. So the double bond. Oh, wait. Sorry. One, two, three, four. 1, 2, 3. Yeah.
And move further to the. Yeah.
Sorry.
Oh no. Oh no. Okay. You have. Okay. Take it down. It's wrong. It's wrong. When your oxygen is single bond, what charge does it carry?
Negative.
So on the left and on the right, both oxygen are single bond, right?
Yeah.
So how come you only have one negative charge, the other one don't have negative charge?
Yeah.
Okay. And then the other one is you forgot that your first step is actually forming the nitrogen. Your first step is you form the double bond between the nitrogen and the carbon. So that means you don't understand mechanism at all. All this while you're just memorizing mechanism instead of understanding what does the electron moving do. Unless you can understand mechanism, you cannot do organic chemistry. Yeah. Okay. At least at A level you can do it, but you will struggle even in medicine university. You gotta understand the arrow pushing idea. Okay. Do you see that? Now you get a double bond there.
Oh
therefore
yeah.
You get a plus.
I forgot that.
And then your final step was you originally have an O minus there. Your final step is you make another O minus because you move the arrow to the oxygen. You know, in the
Yeah.
nucleophilic addition, you move the arrow to the oxygen, right? Then you get an O minus, just like that. Just like that. The difference is the same. You give the electron to the oxygen. Follow your own diagram. You can see.
Yeah.
Can you see your own diagram where you have gone wrong? Okay, that's
Yeah.
because you're
I
just
forgot
drawing a
the
random
double bond.
thing. It's that don't forget this thing, because if you follow your own drawing, if you follow the curly arrow, if you understand what it means by delocalizing the lone pair into the benzene ring, then you wouldn't have messed up like that. Okay, cool. So we can see that when the NO2 is at position 4 relative to the NH2, you can fully delocalize the lone pair on the amine into the NO2 network. So remember that the benzene ring is planar, and then the NO2 is planar as well.
Yeah.
Yeah. Okay. What is the shape at the nitrogen of NH2? So on the phenyl amine, what is the shape at that nitrogen?
For which one? The NH2?
Yeah, at the NH2, not the NO2. We know NO2 is planar,
Oh,
trigonal planar. Just now you said already. What is the shape like at the NH2?
trigonal planar.
Can you tell me why?
Because because it lost its lone pair and now it's a double bond. So now there's 3 bond pair and
Oh
0
no, I
bond
mean
pair.
I mean originally in phenyl amine. I mean before it get delocalized.
Originally. Originally, it's trigonal pyramidal
Okay.
because it still has
So
the lone.
okay, cool.
Yeah.
So the fact that the lone pair is able to get delocalized, can you see planar will be flat like this, right?
Yeah.
So
Yeah.
everything is aligned like that because benzene ring and the nitro group is flat like that. But then the 107 is going to be slightly slanted,
Yeah.
right? Okay.
Yeah.
So it's not a perfect delocalization, and therefore it is still basic, but it's just not very basic. Okay. If it is perfect planar and planar, then the lone pair delocalize fully because very good overlap.
Okay.
107 is not 120 degree. 107 is still slanted away. Yeah. Everything 120
Yeah.
degree, but this side is 107, so it's slanted slightly away. But it can still get delocalized into the ring. So you get the correct idea. You started by saying delocalization, but you were unable to draw mechanism. You were unable to explain it fully in terms of like what you're thinking. You're just saying delocalization. Keyword is important, but what can you understand from it? Okay,
Yeah.
cool. From what we understand here, the lone pair can get delocalized a lot more when the NO2 is at position 4 because as you have drawn, right?
Yeah.
Whereas when it's at position 3, the NO2 at position 3, it's impossible to get the lone pair on the amine into the NO2. It's impossible. You can try it again. If you can get it,
Yeah.
that means you've done something wrong. Okay? So which between the two position is the lone pair on the nitrogen of the amine? Is it more available to accept proton?
More available. The one in the third position.
Okay, that's the
Yeah.
meta position. And
Yeah. The
therefore,
meta
which one is more
position.
basic?
The meta one.
Does it make sense now?
Yes.
Okay, so we started by talking about basicity. What is the base? That one you know. But you
Yeah.
did not extend that idea to like how available is the lone pair because it can get delocalized further into the system. Okay, cool. Are
Yeah.
you ready for the next one?
Yeah.
Okay. Can you draw for me a phenol? Actually, draw two phenol. It's the same
Oh,
kind of scenario again.
okay.
Okay. So on phenol number one, add a CO2H, a carboxylic acid group, on position 2.
Okay.
And then on phenol number 2, add it at position 3.
Yeah.
Okay? Very simple again. Which one is more acidic? And why?
Okay. Just more acidic. Negative. For no. The COH in the second position,
Okay, and why is that?
because that one for that one the lone pair can
What
be
lone pair? Which
the
lone
lone pair
pair?
of the lone pair of the oxygen
Which
of the
oxygen?
okay, sorry, so so the lone pair of the OH group of phenol is able to be delocalized into COOH, and
Really? Okay.
yeah,
Okay.
so when that happens, it is it more readily loses H plus ion.
You
As
think so?
yeah,
It readily loses H plus ion on the phenol or on the carboxylic acid?
on the phenol,
Eh? When you have phenol and carboxylic acid, which one is more acidic?
carboxylic acid.
Eh? So why are you explaining the acidity of phenol then? You're not making
Okay,
sense at
okay,
all. You're just using a textbook answer. But you have a carboxylic acid, which is clearly a stronger acid than phenol. So both have carboxylic acid. I'll tell you the carboxylic acid is definitely the more acidic one. You should know better because your A level is coming out. And if you want an A star in chemistry, you really must be able to get the confusion between these two. Yeah. Okay. Um, and then the acidity, because acidity is on the carboxylic acid, it's not on the phenol. So you shouldn't be thinking about delocalizing into the ring. I said delocalizing the phenol oxygen lone pair into the ring. It doesn't make sense at all.
okay.
Tell me, just now basicity, you know what basicity is, right? What is acidity?
The tendency of the group to lose its hydrogen atom, to lose proton.
Okay, so there's hydrogen ion. Okay,
Yeah,
so it's
hydrogen.
how favorable it is to lose the H plus.
Yeah,
Okay, so it's the same idea. So in which case is the H plus more easily lost? Okay, I will tell you another thing. Acidity is not just about how easy it is to lose the H plus, because when you lose the H plus, you are breaking the OH bond or any kind of bond. You're breaking a covalent bond. Okay, and that requires energy. And the only way for it to be a stronger acid is if your conjugate base is more stabilized. Do you know what's a conjugate base?
yeah. Go
So
on.
when you lose a H plus, you get an anion, right?
Yeah,
Okay. So when you lose a H plus, you get the anion called conjugate base. So the acidity, the relative acidity of a compound is always governed by how stable is the conjugate base. How stable is the conjugate base?
mm.
So tell me, when an acid loses a H plus, it becomes a conjugate base. You get a conjugate base plus
Yeah.
H plus. If the conjugate base is more stable, does that mean you will get a stronger acid or a weaker acid?
Stronger acid.
Because you like to form the conjugate base, and therefore, if you form conjugate base,
Yeah,
you form H plus, and therefore, the more stable is the conjugate base, the stronger is the acid. Okay? Can you draw
yeah.
for me? Can you draw for me in these two cases, the acid, their conjugate bases?
C H. Double bond.
Do you know what is a conjugate base?
Yeah, the
Okay.
COO minus. C. Do I need to draw the benzene as well?
Yeah, just draw the skeleton.
Okay.
I mean, just like how you drew just now, right?
Yeah, okay. Mm. Double bond.
Are you getting stuck?
No, I'm still drawing.
You don't need display formula, you just need skeletal. No one does display. Are you doing skeletal?
Yeah.
Oh, okay. Because skeletal should be just draw the ring and then...
With the double bond. Double bond. H.
If you got the first structure, can I see your first structure first?
I only draw the I so far drew the second one only. The
It's
first one I'm
okay.
still drawing.
Okay, yeah, that's fine. Yeah.
I'm drawing the first one now. Double bond. C. O.
So you are not a very fast learner, yeah. Okay. So that's why like you had to keep on referring to that, because when you were given this problem, you know phenol and phenol, position 2 carboxylic acid, position 3 carboxylic acid, and the fact that you keep on referring to the original thing, you were not having it focused in your mind, okay?
This
And it
one.
took you ages. Oh my god, what have you drawn? Do you know? Can you? Why is the reason why you draw the benzene ring broken?
Because
Because what?
because
Okay,
the
look. First of all, phenol versus carboxylic acid. Which one is more acidic?
carboxylic acid.
Then why in the world do you deprotonate the phenol? Why? You tell me why.
Oh,
You see that?
okay.
You don't touch the phenol because carboxylic acid is going to be the first one that gets deprotonated, okay? So leave the phenol alone.
Okay.
Therefore, benzene ring, leave it alone. And then I just want the carboxylic acid deprotonated. That's the conjugate base. That's how easy it is. So 2 of them.
So sorry, this one.
Yeah, that's fine. The other one? And the other one?
This is the first
yeah.
one. This is the second one.
Okay, cool. Yeah, all right.
Yeah.
So which one do you think is more stable? What can you tell that's so different about them? So you got a carboxylate, right? So the negative
Yeah.
charge is the oxygen of the carboxylate. So you have to decide which one is more stable and why. Only then you're able to rationalize which one is more acidic. So these 2 are the conjugate bases.
Yeah.
So how? Any thought? Any idea? Can you show me a diagram again? Can you show me your conjugate base again? Let me see if I can. On the one at the bottom, can you see that you can rotate? Sorry, you can put your thing down. The second diagram, the one at the bottom, can you see that at the carboxylate you have a benzene and the carboxylate group is single bond, right? Carboxylate is here, and then the benzene is there. Can you see it's single bond, right? Can you rotate about that single bond so that your C double bond, or it's like flip the other way around? It rotates. You can rotate about single bond. So this is what you have, right? Am I correct? Yeah.
Yeah.
Okay.
Yeah.
Single bond, you can rotate about single bond. Double bond, restrict free rotation, cannot rotate there. Single bond can rotate about single. Rotate about this bond, rotate about that bond, and draw me the structure. Rotate 180 degree about this covalent bond. Draw the structure. single bond means you can freely rotate, right? So that's the
Yeah.
idea you must keep in your mind, like, you know, things are not always as you draw it because they can rotate freely.
Is this what you mean?
Uh,
Okay.
no. What you have drawn is a three-dimensional thing. But do you realize that this thing is planar and the carboxylate is planar,
Yeah.
trigonal planar? So when you flip
Mm.
180 degree, do you think it will change to become inside and outside the plane? No, it doesn't. Because it's planar. When you turn 180 degree, it's still planar. It's still planar. Look at this. And then I will turn 180 degree.
Oh wait. Okay.
It's planar, right? You know
Yeah.
shape of molecule, right? You know it's three bond pair and zero lone pair. You know it's trigonal planar. Then how in the world you go from planar to something that looks like it's pointing up? It doesn't do that, right? That is your more specific shape of molecule. So
Yeah.
what can you? So this and this are the same because you're just rotating about single bond. But if I draw it like that, can you see the OH can interact with the O minus?
Yeah.
Can you kind of show me on the diagram how their interaction will be like?
Do I only in one diagram or can I
I don't know.
represent two?
It's up to you. I
Oh.
just want to see how you think, I guess. I mean, I've done the hardest bit for you, man. You should have thought about this. In a real interview, you would need to prove yourself a bit better than this, yeah. So the idea of this kind of thing is to get you thinking, and it's not that everything I tell you will come out, but it's more about can you improve in your way of thinking or not? Are you quick to pick up new ideas, and can you like progress from there, or will you stay the same?
So I think what will happen is that the hydrogen will alternate, kind of alternate maybe.
Oh, oh, mm, no, not really. No, you are kind of going back and forth. Okay, look at what is that? Can you see that?
Oh, yeah.
Okay. Have you heard of H bond before? So
Okay.
again, you are stabilizing it through a intermolecular force kind of thing, and hydrogen bond there is quite strong. You have a hydrogen bonded to oxygen on the phenol. You have a lone pair on the carboxylate, and you only can see that because you can rotate about the carboxylate. And you can only do this at position 2. You can't do it at position 3 because they are so far away. Yeah? And this is a perfect geometry for it. Like six-member ring, right? Can you see that? Yeah. And you can never get this stabilization when the carboxylic acid is at position 3 because it's so far away. You can try it, but you can never do it. So which one is more acidic?
Wait. So the one with the second, the carboxylic acid, the second one.
Yeah, because you can stabilize the
is same.
conjugate base,
Yeah.
right? And how you stabilize the
Yeah.
conjugate base? The hydrogen bond, and you can
By
only see
assuming
because you draw it, and you can only draw it
Yeah.
because the way they give it you like that is not the way you would think about it. You need to rotate about free rotation. Yeah, that's possible. Okay, cool.
Yeah.
Last one. Trust me, this is probably going to be your hardest. Can you draw for me an ethene molecule? No, actually, I'll draw for you. Okay.
Okay.
Rock bubble. Uh, so there's a build one in. Okay. Happy?
Okay. Yeah.
That's it. Explain why. Explain why the product is racemic. Have you heard of the word racemic?
Yeah. Mix 50% of cis and trans isomers.
Huh? Sorry, what?
Sorry, 50-50 of optical isomers.
Oh my goodness me.
Yeah.
Oh, you scared the hell out of me, man. There's a chiral carbon there, a carbon bonded to 4 different
Yeah.
groups. So you started from that, which is well not chiral, and then you become chiral. You have a chiral center. But in this case, in this mechanism, if you just add acid to this, you get this in a racemic mixture. Why? That's it. Can you do this? Can you draw the
Wait.
mechanism?
Wait, what's the structure again? Sorry, I have to copy it.
Build one in. So that is build one in.
Okay. And OH. Okay, thank you.
The question is just basically, why in the world do you get a racemic mixture? Or explain with mechanism how you get a racemic mixture.
Okay. So OH. H.
What have you done so far?
Still thinking.
And this is in your AS syllabus, yeah? Trust me, it is.
Okay.
Show me your mechanism so far. I just want to see where you are right now.
I haven't drawn anything yet. Okay.
What have you got on the paper? Okay, so there's H3O plus.
Yeah.
Okay. Okay, cool. Do you know what a H3O plus is?
It's basically it's basically the acid group.
Yeah.
Yeah.
So S is in water anyway, right? So a substance that dissolves in water to give you H plus. When you have H plus, you must have water. And the H plus don't like to be alone. When you have water and H plus, they're bound to give you H3O plus. It's an equilibrium. So it's a source of H plus. So what is alkene gonna do with H plus?
And it will donate its double bond
Show
to
me.
the.
Show me mechanism.
Okay.
What kind of mechanism are we talking about?
Nucleophilic addition.
Show me the mechanism.
Wait. Is it something like this?
Yep. And on the H3O plus, you know when you form the active bond, your charge is no longer on the free H plus, it's now on the on the oxygen.
Yeah.
And why are you drawing the plus on the on your diagram then? Why are you drawing the plus on the hydrogen? It should be on the oxygen, yeah?
Yeah.
You can lower your diagram. You can lower your diagram now. Your oxygen is
Okay.
3 covalent bond. Your oxygen is 3 covalent bond. It should have the plus there. Just like NH3 is neutral, when you add the H plus, the plus is no longer on the proton, it's on the nitrogen because the nitrogen form 4 covalent bond. It's the same there, okay? Cool. So after that, what happened? And by the way, you are extremely wrong. This is not nucleophilic addition. This is electrophilic addition, man. Alkene chemistry.
Yeah.
You know your AS is coming up, yeah. Okay, come on, mess up, yeah. Okay, if you still cherish your A level, okay. Anyway, so what are you gonna form?
Sorry, what's that?
What is the next step?
Yeah.
What's the next step? Mechanism.
So
Draw
for
for me.
the okay.
Picture speak 1,000 words. It's easier to see from your diagram where you have gone wrong or where you've.
So in this case, oh,
Yeah, okay, you must be so tired.
wait. Sorry. Okay. Plus. So since it, oh wait, where is it? So because it
What do you call
so
that?
since it,
What kind of species is that?
carbocation.
Okay, is that the only carbocation you can form?
Oh, sorry.
Is
Yeah,
it?
that's another one in the hydrogen.
I don't know. Where is
Yeah.
it? Okay. Wait. Are you saying that you get a compound with 2 plus?
Sorry, what's that?
How come you have 2 positive charge there?
Wait.
Look, man, this is your always practice on past paper. When you attack the H plus, what can happen? The hydrogen can go to one side of the alkene, or it can go to the other side of the alkene.
Yeah.
It goes to one side of the alkene, it gives you a secondary carbocation, or it can go to the primary carbocation. Have you learned this before? Yes.
What was that?
Hello.
You mean
Have you learned this in
hello?
school before?
Oh yeah.
Have you learned this
You
in
mean
school before?
you mean the hydrogen where the hydrogen attacks
I
in the
mean,
double bond?
No, I mean like the mechanism. You learn in school as bromine, right?
Yeah.
The bromine can go
Yeah.
there, or the bromine can go
Or
there.
it can
Can you
go
see it's
the
the
other
same
side.
concept?
Yeah.
Yeah. Can you see that between the secondary and the primary carbocation? Can you see that secondary carbocation is more stable because of the two electron donating alkyl group?
Yeah.
You've done this in past paper, right?
Some
Have
similar, I
you?
guess.
Yeah, of course it's similar. It's the same concept. Okay. This is the carbocation intermediate. This is a methyl group, CH3, methyl. This is a ethyl group, CH2CH3, ethyl. There is a hydrogen because I have drawn skeletal. Hey, guess what? One, two, three. Carbocation is three bond pair, zero lone pair, planar. Hey, this thing is three different group, and they are flat. They are planar. Carbocation, planar. So where can the nucleophile attack then? Which one is the nucleophile? You have a H plus. The only nucleophile that makes sense is water because H plus cannot be a nucleophile. H plus does not contain any electron at all. How can you have lone pair, right? Where can the water attack? The water can attack from the top or it can attack from the bottom. And if there's equal chance of the water attacking from the top or from the bottom, you get racemic.
Oh.
Did you know about this? In your SN1 reaction, it's trigonal
Yeah.
planar intermediate. The nucleophile can attack from the top or from the bottom. If your carbocation intermediate contain three different group and your nucleophile is a fourth different group, you will get racemic. For that reason, because you have equal chance. Look,
Yeah.
when they are flat like that, what makes them not attack from one side and the other? Nothing, right? I mean, it's totally flattened. Right? So the
Yeah.
nucleophile can attack from the top or from the bottom with equal chance statistically. And therefore there's 50% with the OH group is on top or the
Or
OH group is
bottom.
at the bottom. Mirror images. What
Oh,
have we
okay.
done today? What have we done today? All we have done is mechanism. What have we done today? We have taught nothing more than your first year AS level chemistry, electrophilic addition mechanism, intermediate, shape of molecule, stability of carbocation. We have talked about relative acidity and relative basicity. There's a bit more on A2 organic chem, but again, it's the same idea of what makes things acidic, what makes things basic,
And
and between
yeah.
base and base, which one is slightly more basic, which one is slightly less basic. You get most of the general idea, okay, but your problem is in explaining yourself, and your problem is in becoming more confident in applying your ideas. And also, if you get an interview, you need to be quick thinking on your feet and pick up new ideas more easily rather than like very focused on just using your prior knowledge because they are trying to teach you new things. Like I'm trying to guide you along the way here, but there are times when you were quite stubborn and then you were like trying to go back to your usual way of thinking. You should have tried to pick out what I was trying to say because it's called take a hint. They will try and give you hints. If you do get an interview, that's how it will work. Trust me, one of the interview for biochemistry will be organic chemistry. There will be mechanisms and stuff where you are expected to explain your ideas and curly errors,
Mm.
all these things. It's not just what you learn in textbook. You need to be able to explain it because that's why that is the reason for everything. Okay, structure and reactivity.
Mm.
Okay, okay with what we did.
Sorry, what do you?
I know it's end of the day.
Sorry.
I say I know it's end of the day, and I know you're tired
Oh,
and things. But when you have time, do like go through your AS chemistry or AS biology, and it would really help in the revision as well to try and think things a little bit deeper rather than just do a lot of papers and then just get on with
yeah.
it. There's a reason for everything. Why do you move this arrow here and there? There's a reason, okay? And be very careful with charges and your shape of molecule and yeah, all those little things that will cost you marks in AS and also A2, yeah? Okay?
Yeah.
Cool. I'll leave it there. If you got question, just text me or something. In the meantime, you should be finishing up your UCAS stuff. Otherwise, you will still be in the middle of it, in the middle of your AS level exam. Okay?
Okay.
Cool. All right, we'll leave it there then. Okay. As for next week, we'll see how busy you are first. Then you just let me know if you want another session, yeah? Okay?
Okay.
Cool. All right. Bye.
Okay. Okay. Thanks, sir.
Okay.